Hey everyone, I'm Richard, and well, let's just stop for a second as I've got something I want to show you. This is Doom 2016 running at 1080p on ultra settings on a desktop GTX 1060. Looks pretty decent, right? Silky smooth frame rates at 60 FPS and beyond, locked full HD resolution and zero compromise on quality presets. So what if I told you that you could play this on a 14-inch laptop? That's the experience I had recently at an Nvidia press event. The Razer Blade 14 equipped with the Pascal powered GTX 1060. Pretty staggering actually when you think about it, as it's delivering more CPU and GPU power than the upcoming PlayStation Neo in a small, thin laptop. That, my friends, is what we call a game changer. So yeah, it's all about the transition of Nvidia's Pascal technology to mobile. Now typically, we see reduced memory bandwidth, fewer CUDA cores and lower performance, comparing say the GTX 980 to the GTX 980M, but not this time. Check out the specs. So yeah, GTX 1080, 1070 and 1060. There's no M's this time, and that's because, well, they're effectively on par with the desktop versions. 1080 and 1060 share the same CUDA core counts. Memory bandwidth, exactly the same as the desktop versions. So yeah, the 1080 even gets full-fat G5X RAM. Curiously, GTX 1070 actually gets more CUDA cores than its desktop equivalent, and that's because their boost clocks are lower, so it sort of balances out. It's almost too good to be true, so I wanted to test it out. Now you might have noticed this gaming laptop colossus I have here. That's the Asus GX700VH. Core i7 CPU, Pascal GTX 1080 in SLI, and it's even got a bolt-on water cooler to boot. Quite frankly, it's a monster. Now we're going to be reviewing that in due course, but in the meantime, I wanted to run it using just one of its GTX 1080s to get an idea of how performance stacks up. The first thing I noticed off the bat is that while the Nvidia boost spec is at 1733 MHz, like the desktop part, well, on this machine at least, it actually ran at around 1650. Our Founders Edition 1080 tops out at around 1866 MHz. So while all the CUDA cores are indeed there, it will run slower, and it does, but not by much. Nvidia told us that there's a tolerance, if you like, of around 10% of wiggle room. With the Asus here, the desktop version is around 7% faster. That's still pretty remarkable though. Nvidia did a proof of concept on using desktop technology in its laptops with the last-gen Maxwell GTX 980. But really, the last-gen flagship was the GTX 980M. It's not a bad part really for 1080p gaming. But in desktop terms, it sort of sits between GTX 960 and GTX 970. Stack that up against the notebook GTX 1080 and, well, its performance in the new era is almost embarrassing. In this Crisis benchmark, you can see that the notebook GTX 1080 is a lot faster at 1080p. In its standard form, 92% faster. Now you'll also see a max benchmark reading there. When the Asus is docked into its water cooler, it actually returns to the full boost clock. In fact, there's even a mild overclock I've disabled here. Now we're pretty much twice as fast as the GTX 980M with that cooler active. So yeah, I would expect to see a slight reduction in performance on the notebook parts compared to their desktop counterparts. But what's clear is that we are looking at a huge leap in performance. The 980M, yeah, as I said, it's a decent 1080p part. GTX 1080 is actually viable for 4K gaming. Based on its desktop performance, even with a 10% drop in frame rates, the Pascal GTX 1060 will wipe the floor with a 980M. Pretty astonishing stuff actually. And by extension, the GTX 1070 notebook chip should in theory provide Maxwell Titan X performance. But there are other innovations too, like desktop level overclocking. Nvidia demoed an MSI laptop running GTX 1080 at 2 GHz, pretty much on par with how far you can push the Founders Edition. Well, without the water cooler in place, I couldn't match that with the Asus here, but with it attached, okay, so let's really push things. Assassin's Creed Unity, 4K. Here we've stacked up the GTX 1080 Founders versus the notebook version. Oh, and how about two mobile GTX 1080s in SLI, overclocked and compared against the Pascal Titan X? Well, the results speak for themselves. By the way, for those wondering, the water cooling is actually pretty decent. Both GPUs with the overclock in place are running at around 70 degrees Celsius. I mean, it's utterly insane, stupendously expensive, but come on. It's brilliant, right? But let's return to more realistic use case scenarios. Back in the day, Nvidia launched Battery Boost, an attempt to get a good compromise between power efficiency and performance when running on battery. When Tom looked at the results of it, well, it wasn't pretty at all. Take a look at the frame time graph there on the right. What you're seeing is some pretty horrendous lurching and stuttering. Whether you're running Battery Boost or not, consistency in performance just wasn't there. Right then, I wasn't planning on testing this during my initial analysis, but as it happens, I accidentally ran a Division 4K benchmark with the GTX 1080 here when the laptop was disconnected from the mains. And the data there was actually pretty useful. Compare it with the same benchmark rerun with the PSU connected, and we can see two things. First of all, of course, there is a performance penalty. We get about 70% of the full fat experience running on battery. Boost clock is actually at about 1150 megahertz here. Now that's not bad, but the second factor to consider is frame time. The judder and the stutter that we noticed before, it's all gone. Now the cool thing here is that this is a software fix, and Nvidia tells us that this rolls out to all existing users of Battery Boost, not just those who invest in the new Pascal technology. Okay, so look, I'm a bit worried about the state of the PC components market. Intel bosses the CPU side, and we're waiting on AMD Zen to make a difference there. On the desktop GPU side, well, Nvidia has at least 77% market share there based on the various analyses I've seen. But on the notebook side, Nvidia's share, by their own admission, is anything between 90 to 95%. I don't think it's healthy for the market, but at the same time, Nvidia has earned this position by producing by far the best, most power-efficient notebook gaming solutions available. Maxwell was pretty good, but Pascal, well, Pascal is awesome. This Asus here, well, they reckon with its twin 1080s, it's the fastest consumer laptop on the planet. And they're probably right, but I can't help but recall that Doom experience I had at the Nvidia presser. GTX 1060 is actually the least capable Pascal part Nvidia revealed, but by extension, it's also the cheapest, and it draws the least power. And that means it can fit into a chassis as small as the Razer Blade 14s. Gaming laptops tend to be big, bulky devices, but Pascal delivers enviable GPU power that can fit into everyday sized devices. Now from my perspective, that's pretty exciting, and I can't wait to see more. Okay then, I hope you found this particular video insightful. Please let us know what you think of this in the comments, and like and subscribe to support our work. Thanks for watching.